Hello and welcome to this week's Citizens Climate Training Program. It's a weekly webinar of Citizens Climate Lobbies that provides CCL supporters like you and I with access to in-depth training opportunities on topics related to climate change and effective climate advocacy. I'm your host, Brett Cease, and tonight we're going to dive into what is in the fifth National Climate Assessment Report. We're going to be joined here by CCL's research coordinator, Dana Nuccitelli, for a training that will discuss the latest landmark National Climate Assessment Report, which is an essential American-specific version of the IPCC report outlining climate trends across regions, impacts, and solutions for each of the states in our country. With that, a little bit more about our speaker. Dana is an environmental scientist with degrees in astrophysics and physics, and as a climate journalist with Skeptical Science, The Guardian, and Yale Climate Connections, and the 2022 SEAL Award winner for his climate journalism. And if we've done our job well, here are the following three learning goals we're going to cover tonight. What is the fifth National Climate Assessment Report? What does the report tell us about the global climate? And how can we learn from the report what it tells us about each of the regions in the United States? So with that, thank you all so much for being here. You're in for a real treat, and I'll pass it to you, Dana, to take it from here.
So let's start out talking about what this report even is. Congress passed a law in 1990, the Global Change Research Act, that tells the U.S. Global Change Research Program that it needs to publish these regular reports talking about what's happening with the climate. The purpose is to understand, assess, predict, and respond to human-induced and natural processes of global change. They're supposed to be published about every 4 years. Sometimes they get delayed a little bit. So they were published, the first version in 2000, and then the second in 2009, and 2014, 2018, and 2023. Between 2000 and 2009, they had published some smaller reports as well. So this was the fifth one in 2023, and it's basically the US specific version of the IPCC reports, meaning that it is our top climate scientists summarizing the latest and greatest climate science research, but specifically about what's happening in the United States. So it's a pretty cool report. Lots of great information that we're going to talk about tonight. So you can see this is kind of the table of contents here. There are 32 different chapters, plus additional sections focusing on specific types of important things like wildfires, COVID-19, and things like that. You can see there's also a chapter on each different section, each different region of the United States. So we're going to quickly go through each one of those tonight. That's going to be kind of the main thing. But first, we'll talk about some of the broad picture before we get into each specific region of the country. So some of our key takeaway points from this report. One is that the United States is responsible for our cumulative historical emissions, about 17% of total global warming, despite only having about 4% of the world population. So we're really punching above our weight in terms of causing global warming. You can see on the right this chart that Carbon Brief put together of cumulative emissions, and you can see here's the US, and then behind us China, Russia, the United Kingdom, and so forth. So lots of emissions that we've caused. But the good news is that our climate pollution peaked in 2007 and has fallen 16% since then. So falling at about 1% per year over the past 15 years or so. So making some progress, a little bit slow, but emissions are steadily going down, pretty much because we've been replacing coal with cleaner electricity sources. Some other good news is that our wind and solar costs fell 70% and 90% respectively over the past decade. And those two sources of electricity have accounted for over 80% of the new capacity that we've added over each of the past 3 years or so. And you can see that on this chart, which on the top in the blue, we're looking at the costs of wind, solar, and EV batteries from left to right. You're seeing those going down over time over the past decade. And then on the bottom in the yellow, you're seeing the amount of wind and solar and EV sales that we have deployed over that same period of time. So of course, as the costs have come down, we've deployed more and more of these clean technologies. So that's where we're making some good progress. So some more general takeaway points. Extreme weather, as we know, is getting more frequent and more severe for a bunch of different types of extreme weather. Climate change is also worsening inequality in the United States. More vulnerable communities that are tending to be more impacted by climate change extreme events. They then often don't have the resources to as easily rebound and recover from those events. And so it kind of worsens our issue of income inequality. Climate change is also bad for the economy in general, and specifically, the report found or concluded that climate change is probably slowing economic growth, which is important because growth compounds over time. So, if the economy is growing less slowly than it would otherwise have, that can add up to a lot of very expensive costs over the long term in the trillions of dollars. The good news is that green jobs are booming as we transition to those clean technologies that we saw in the last slides. And so those solutions that we're deploying are great opportunities to not only reduce climate pollution, but also create more jobs and nice financial and economic benefits as well. So let's talk a little bit about that extreme weather really quickly. Here is the latest chart of the billion-dollar extreme weather disasters that happened in the United States in 2023. There were 25 of them. You can see a lot of these are severe weather events, really big storms that had significant impacts on local economies, often because they cause flooding and related impacts on our infrastructure. And you can see, excuse me, on this chart, how the number of billion-dollar weather disasters in the United States has changed and increased since 1980. So that's you can see that increase over time, especially in the green, which is severe storms, the number of severe storms that have caused $1 billion in damages or more. So we're just seeing more and more of these extreme damaging events over time. And then an important thing to bear in mind, which we'll look into as we go into each specific region of the country, is that climate change has different impacts on different regions. And this chart on the right illustrates that nicely. What we're looking at is change in precipitation across the country over the past 100 years or so, with kind of greenish bluish being more precipitation and yellowish brownish being less precipitation. So you can basically split the country in half, and most of the eastern half of the country has gotten wetter. Most of the western half of the country, especially the southwest, has gotten drier. And so that has different impacts in terms of drought and wildfires and heat and stuff like that. So now we're going to see those different impacts in different regions. And you can see this map on this chart shows the different 10 different regions that the report broke the country out into. And so we're going to kind of go through each one of these and really quickly touch on kind of the main points that the report talks about for each individual region. And we're going to start with the Northwest, which is Washington, Oregon, and Idaho. And so in that region, the main climate impacts they have to worry about are heat and flooding and wildfires. And one issue that they're experiencing is shrinking snowpack because as you get higher temperatures, you get more precipitation falling as rain and less as snow. And the snowpack also melts earlier in the year. And so as our snowpack shrinks, that has problematic consequences for our reservoirs. And so reservoirs, especially in kind of eastern Oregon and into Idaho, have been becoming more depleted as a result of those shrinking snowpack. And then this region also is vulnerable to extreme heat, as we saw in the summer of 2021 when there was that really intense Pacific Northwest heat wave with temperatures, prolonged temperatures above 100 degrees Fahrenheit, which caused a lot of illnesses and deaths and all kinds of problems because the Pacific Northwest does not normally get above 100 degrees. And so they're not really prepared for or adapted to that kind of extreme heat. And so it's a good example that we kind of have to anticipate these kinds of extreme weather events and try to prepare for them as best as we can to try to minimize those kinds of adverse impacts. Another issue is atmospheric rivers in the Pacific Northwest, which can cause flooding. And you can see that on this nice chart from the report on the right, which the red here is kind of the potential path of an atmospheric river, which then basically it brings a whole lot of water and dumps all that water in the form of extreme precipitation when it passes over the land. And so now, because the atmosphere is hotter, a warmer atmosphere holds more water vapor, and so that can result in atmospheric rivers having even more extreme precipitation than they used to. So you can see on the bottom here that especially in winter, kind of the darker colors here are basically more increase in the number of days with extreme precipitation associated with atmospheric rivers. So especially in the winter, you were seeing a lot more of these intense atmospheric rivers causing lots and lots of extreme precipitation also in the fall in the Pacific Northwest. And then in terms of emissions and finding solutions, transportation is the big one that we are looking at in the Pacific Northwest, which we can see on this chart showing the carbon emissions by sector. And so you can see all of them have been pretty flat over the past 20 years or so, but the big one is transportation. Electric power, electricity is pretty clean in the Pacific Northwest because they've got lots of hydroelectricity. So they don't so much have to worry about decarbonizing electricity because it's already pretty clean, but transportation is kind of the tough nut to crack in the Pacific Northwest. So that's where they would benefit from focusing their efforts, doing things like finding ways to transition to more electric vehicles and improving bus public transportation and other options like that. So let's shift over a little bit to the south, to the southwest, which is basically the states between California and Colorado and New Mexico. Where here our main climate impacts are heat and drought and wildfires. We also have issues with our water supplies, which are already stressed and they're under increasing pressure as, again, the snowpack shrink, or for the same reasons as the snowpack is shrinking in the Pacific Northwest. So that poses an issue for our water security and supplying enough water for all our needs. Heat is also a big problem in the Southwest, which we especially saw a very good example this year in Phoenix, which had 31 consecutive days and 54 total days this year above 110 degrees Fahrenheit. So very dangerous levels of heat that, again, something we have to be prepared for in the future in more locations. And another important sector is California's agriculture, which provides a lot of different agricultural crops for the rest of the country and the whole world, and is threatened by, especially by drought and by the water security issue, and also by extreme heat. So this is something that everybody should care about, even if they don't live in California, because California produces 2/3 of all fruits and nuts grown in the United States, including nearly all of the crops listed here: almonds, artichokes, avocados, broccoli, and so on and so forth. So if you like any of those foods, as you should, because many of them are very delicious, then you should be worried about California agriculture being impacted by climate change and water security. Specifically, California also produces 80% of all the almonds in the world, which are worth $6 billion per year to the California economy. But almonds are a very water intensive crop. And so that's been a problem as we have lacked sufficient water for all our needs. And so there's been some cases of farmers having to rip up almond orchards and try to look for some less water intensive crop to replace them with. But then again, we're the main source of the world's almonds. And so then you potentially don't have as many almonds as you used to, and that could be an issue. So this is a very nice graphic from the report that shows all the different interactions between agriculture and climate change in the Southwest. So again, we have that reduction in the snowpack, which reduces our surface water availability from the snowpack melting and refilling our water supply. We have food security risks as a result of stressors on our agriculture, extreme heat causing problems both to crops and to workers and livestock, droughts causing problems for our water supply, Because we don't have enough surface water, we have been extracting a lot of groundwater from our aquifers, but that is not sustainable because then we're depleting our groundwater aquifers. And so there's a lot of these issues, and then soil is becoming drier because it's hotter. So all these different issues interacting and impacting our water supply, especially which then impacts our agricultural productivity. So something we need to minimize by minimizing future global warming, and also something we have to adapt to by finding more efficient ways to use our water and reuse our water. So let's shift over now to the northern Great Plains, which is Montana, Wyoming, the Dakotas, and Nebraska. So their main climate impacts are drought and flood and wildfires, and also hail, which was an interesting one. There was a study that looked at hail risks as a result of global warming in the future, and found that the largest increase in hail risks in the country are in this region in the month of July. So obviously, if you have lots of big hail falling, that can do significant damages. So that's an interesting impact that I wasn't aware of until I read this report. The economy of this region relies heavily on fossil fuel extraction and agriculture. And so, as we transition away from fossil fuels, there is a concern of the loss of a lot of fossil fuel jobs in the region. But the good news is that this region also has lots and lots of especially wind energy potential. So there could potentially be a transition of workers if we can retrain workers to work in that region, and just switch the economy to a cleaner one. That's, of course, easier said than done, but we would like to see some programs to help make that happen. And then the agriculture in this region is going to be under pressure from different changes as a result of climate change, changing temperatures, changing moisture, changing carbon dioxide in the atmosphere, and changing ozone levels. So you can kind of see some of those impacts on this nice graphic from the report. On the left here, we're looking at some of the things that's happening with row crops in this region. So again, you got shrinking snowpack, reducing your surface water supply and availability. One benefit is that because this is a relatively cool region right now, as we get more warming, then the growing season actually becomes longer and there's more frost-free periods. So that's actually beneficial to agriculture in this region. But with that comes also increased potential for weeds and damaging pests to move in because they like the warmer weather as well. And then you also have heat stress and moisture stress from drier soils, which are not so good for growing crops. So there's kind of these competing effects. And so there's potential for some of the land currently used for agriculture to become not so suitable for agriculture. And so for the parts of the region where that happens, then the report kind of suggests you could do some land use conversion from farming to grasslands, and let some grasslands grow, which then improves biodiversity. It lets more pollinators come in, which is good for the crops nearby that are remaining agricultural land. And the native grasslands can then sequester more carbon and help us as a natural climate solution. So that's not something like we don't want to have a massive switch from agriculture to grasslands because we still need to grow that food, but just kind of the some of the land that becomes less suitable for growing crops could be switched in this way. So now we're going to shift down to the southern Great Plains, where we've got Texas, Oklahoma, and Kansas that have to worry about heat, drought, flooding, and sea level rise. And in fact, the Gulf Coast has the highest rate of sea level rise in the United States because not only do they have rising sea levels, but they have subsiding land. So it's kind of a dual effect there that causes more encroachment of sea levels onto the coastline. Texas is also the state with the highest carbon dioxide and methane pollution, but this region supplies 42% of all the wind energy in the United States right now. So it's like a very energy important region, both for fossil fuels and for clean energy, which is interesting. And in fact, solar energy in Texas is also growing very, very fast and is expected to increase eightfold between 2020 and 2025. So while it's got lots of fossil fuels, it's also got lots of clean energy potential and clean energy growth. So in terms of the methane emissions, you can see that on this chart where redder parts of the map are showing where there are significant methane emissions and methane leaks. So you can see this zoom into this region in the western part of Texas and into the corner of New Mexico. You've got particularly dark red region where you're seeing the Permian Basin, where there's lots of oil and gas drilling, also creating a lot of methane leaks. And so that's why Texas is the state with the most methane emissions, because there's a lot of oil and gas drilling that results in a lot of leakage. And so we would like to address that leakage. So it's something that oil and gas companies are going to be working on. There's going to be EPA methane regulations coming out. And of course, we have now a federal methane price to back up that EPA methane regulations. So hopefully we will soon see some of this red disappear as oil and gas companies reduce their methane emissions from their practices. But as I mentioned, very good news here is the amount of wind coming from these three states. You can see at the dark blue at the bottom here is the amount of wind from Kansas, and then here's Oklahoma, and then Texas in the light blue here. And then here's the amount of wind being produced in gray by the other 47 states. So you can see a really big chunk, 42% of our wind power in the United States is being produced by just these three states. So they're doing very, very well in producing some clean electricity there. And hopefully they will continue that transition and building up that clean energy economy and jobs and revenues coming from clean energy in those states. So that's a nice story there. And then here's a couple of impacts on the left, looking at precipitation changes, and on the right, looking at really hot days above 100 degrees Fahrenheit, how they're going to change on our current path by the middle of the century and the end of the century. So you can see a lot of Texas, especially, and kind of the western part of this region becoming drier with less precipitation, especially in southern Texas, as the region gets warmer. And also, of course, as everything gets warmer, we're going to see more of these extreme hot days, looking at from 10 to 50 or 60 in southern Texas, more days than there are now per year above 100 degrees Fahrenheit. So lots of potential extreme heat problems. Again, I mean, the further south you get, the closer you are to the equator. And so the closer you are to 100 degrees already. And so that's why you see more days as you get further south, going above 100 degrees Fahrenheit. So again, something we want to minimize as best as possible by hopefully reducing emissions further than we are on the path for today. And then we're also going to want to be as prepared as we can and as adapted as we can to become resilient to those extreme heat days. And then shifting a bit over to the east to the southeast region, here, lots of states between kind of Louisiana and Virginia and Florida. Here we have to worry the most about heat and hurricanes and sea level rise and flooding. There's a lot of pretty fast population growth in this region, especially in the cities. A challenge there is that cities have an urban heat island effect, where you got lots of asphalt and concrete that kind of radiate heat and make cities particularly hot. And now we're seeing more and more extreme hot days. And so that's kind of a problem with all these people moving into these particularly hot spots. So those cities are going to have to be as resilient as they can be to extreme heat by doing things like planting more urban trees and creating more shade and things like that. And also a lot of people moving to the coastlines where we have to worry about sea level rise encroaching on the coast and coastal property. So hopefully people will not move right onto the beach so much and maybe move a little bit more inland where sea level rise isn't as much of an impact. Lots of extreme heat in this region, which is bad for labor productivity, especially for outdoor labor. Also, agricultural productivity is threatened in this region by the combination of drought and extreme heat, and also sometimes extreme precipitation, all not so good for crops. And then one issue is that a lot of these states don't have comprehensive climate adaptation plans, which, given all the impacts that they are vulnerable to, sea level rise, extreme heat, all these things that really could use adaptation plans to become more resilient against those impacts. That would be really helpful if they would develop those kinds of plans. You can see an example of that from this chart, again from the report, where we're looking at the projected infrastructure costs in a scenario on the left when we do take adaptation measures, and on the right where we don't take adaptation measures. So you can look at Florida, for example. In 2050, you're talking about about $1 billion per year in infrastructure costs from extreme weather if we do adapt, and almost $2 billion per year if they don't adapt. So it's a very big difference, talking about close to a factor of two and lots of money. And so this is why creating these adaptation plans and trying to minimize these impacts as best as possible and become resilient to them is very important for people's health and for the economy, because these are very expensive potential impacts. And overall, this region is very economically vulnerable to climate change. So you can see this chart on the right is from the report. This is in a worst case scenario in 2100. This is kind of if we backslide on our current emissions and cause a lot of warming. But you're looking at the total economic damages throughout the region. And it comes from this paper. You can see the chart on the right is the chart from the original paper. So it shows the whole country. And so you can see basically darker is bigger economic adverse impacts from things like hurricanes and extreme heat, worse lessening labor productivity and impacting agriculture, and all these different impacts kind of being combined. So like the northern part of the country where it's already relatively cool, they do not, their direct impacts aren't so bad on the economy. But it's the hotter regions, especially in the south and the southeast, that are especially hard hit by all these climate change impacts from the heat. And also they've got the coastline, so they're impacted by worse hurricanes as well. So this is the region where they'll really benefit from both mitigation and adaptation to try to lessen these impacts as much as possible. Again, this is a worst case scenario, so we should be doing much better than this as long as we don't backslide, but it's a good illustration that this is a particularly vulnerable region to a variety of climate change impacts. So let's shift up to the north now, into the northeast, where here water is the main issue, extreme precipitation and flooding especially, also extreme heat. A good example we saw just this July, this summer, where we got the intense precipitation in Vermont and New York and caused a lot of damaging flooding there. There's also issues off the coast with the marine ecosystems warming. And as a result, fish are kind of shifting to the northeast and also to deeper waters to kind of adjust to the ocean warming. The good news in this region is that almost every state has done a recent climate impact assessment or action plan and enacted climate related laws in just the past few years. So this is a very proactive region in preparing for and trying to mitigate climate change. So doing a good job up there with that. So here you can see over the past 50 years or so, the increase in extreme precipitation days with more than 2 and 3 and 4 and 5 inches of precipitation. So you can see this long-term trend. There's a lot of year-to-year variability, but this long-term trend with these extreme precipitation events becoming more and more frequent and thus causing more and more flooding damages. And then this is a cool chart also from the report showing the changes to the Gulf of Maine ecosystem as the oceans get warmer. So you can kind of see the changes since 1985 to roughly today and then what's going to happen by 2050. So the arrows kind of give you an idea what we're expecting in the future, where like populations of puffins and herring and cod and lobsters are expected to decrease due to the warming of the Gulf of Maine. Right whales are going to migrate more out of the Gulf of Maine. We're going to see more squid and black sea bass because those are populations that are more accustomed to kind of temperate, warmer water. And so those will kind of move in to fill in where these other species are moving out. So it's going to be a bit of a challenge for the fishing industry to adapt to, but they'll kind of have to recognize these shifting populations and adapt their fishing practices accordingly. All right, so moving over to the Midwest, here the main concerns are extreme precipitation and heat and drought. This is another very big agricultural region, especially for corn and soybeans. It produces more than 30% of the world's corn and soybeans, with over $50 billion per year in economic productivity just from those two crops. So the crops in this region are going to be challenged by extreme rain and also by rapid shifts between very wet and very dry conditions, which we'll see here in the next slide. And there's also some old infrastructure in this region that those extreme heat and extreme precipitation are going to create more stressors on and could potentially cause some problems if the infrastructure is not updated. So here we can see the change in it's the frequency of transition between precipitation extremes. So going for example, from a very dry month to a very wet month, and those shifts cause a lot of stress on crops and infrastructure. Basically, you can see the redder is a bigger, higher frequency. So more frequently, you're seeing this shift from a dry month to a wet month. So you can see not too much change so far, a little bit in Michigan, but not a huge change so far. And then you're looking at three different scenarios. The first one here is if we meet the Paris target, stay below 2 degrees. This is the current path we're on, heading towards closer to 3 degrees, and a worst case scenario if we backslide on our emissions cuts and get closer to 4 degrees. So you can see the warmer it gets, the redder it gets, meaning we're getting more and more higher frequency of these shifts between really wet months and really dry months. So that means more and more stress on agriculture and on infrastructure. The more warm it gets, and thus the more of these shifting precipitation patterns that we get. So again, the more we can mitigate global warming, the more we can mitigate these stressors on our agriculture and our infrastructure. And then this region also has to worry about wildfire smoke. We saw an example of that this summer with the wildfires in Canada, in Ontario, and the smoke coming down into this region. Also, in general, on the right here, you're looking at a map of the wildfire seasons between 2016 and 2020, which were very bad wildfire seasons in the Western United States, and a lot of that smoke kind of drifted over to the Midwest. So it's just kind of an area that tends to get a lot of smoke from other regions. So even though the Midwest isn't under threat from wildfires in the region, it's under threat from smoke, which is very unhealthy and not good to breathe, coming in from wildfires increasing in other forested regions like the Western United States and Canada. And then moving up to Alaska, most of the issues here are related to melting ice and stuff happening to the oceans. So they've got thawing permafrost, shrinking glaciers, and melting sea ice. The seafood industry is really important in Alaska. It produces $6 billion of revenue and 60% and 31% of the value of our total U.S. fishery catch. Counts for 60,000 jobs and almost $2 billion in wages in Alaska. So, very important sector there. And climate change has already harmed marine fish and salmon and crab populations in Alaska. The good news there is that there are opportunities for marine aquaculture, for fish farming, to kind of make our fish industry there more resilient against climate change. You can see on this nice graphic from the report that there have been a lot of different climate-driven extremes in recent years in Alaska. You're talking about things like sea ice shrinking, ocean acidification, especially high north of Alaska, a lot of precipitation and flooding in the summer in eastern Alaska a couple years ago, and also a summer heat wave in southern Alaska, a drought in southeastern Alaska, some record wet summers. There was a big blob marine heat wave over here that had lots of adverse impacts on marine ecosystems and just south of Alaska. So lots of different climate change impacts, different types of impacts around Alaska there. And then let's move over to Hawaii and the other Pacific islands, where they, of course, have to worry about sea level rise, big problem for islands, also droughts and heat. Those factors cause food and water insecurity, as do changing rain patterns and degrading fisheries off of their coasts. Marine ecosystems are threatened by rising ocean temperatures and ocean acidification, and coastal ecosystems are threatened by sea level rise, encroaching on their coasts. And we're also seeing some more heat and droughts, which can increase fire risks, as we saw in Maui this past August, where their invasive grasses caught fire and caused all kinds of devastation, which those conditions were exacerbated by a lot of heat and dry conditions. Really nice graphic here from the report looking at all the different climate impacts on these Pacific islands, things like more intense and frequent heat waves, these invasive species and wildfire risks, those invasive grasses, impacts to water supply from changing precipitation patterns, shifting fisheries and biodiversity loss from things like ocean acidification and warming, sea level rise causing saltwater intrusion on the water supply, declines in water quality as a result, impacts to crops and food security. So lots of different climate change impacts to these Pacific islands summarized very nicely in this chart. And then I think the last region we're going to look at is the Caribbean, specifically looking at Puerto Rico and the Virgin Islands. So here, of course, they have to worry about hurricanes and sea level rise, also extreme heat and extreme droughts. So those factors and also reduced rainfall can cause food and water insecurity in these islands. They're also quite dependent on fossil fuel imports, which creates a lot of energy insecurity. But there's a lot of opportunities for infrastructure improvements, switching to potentially distributed renewable energy sources that could create a lot of economic opportunities associated with installing that infrastructure and also help limit their vulnerabilities to climate change by making them more resilient, less dependent on these imported fossil fuels. So this is another nice chart, nice graphic from the report that looks at the climate impacts in particularly wet and stormy events like hurricanes and when there's a particularly intense dry scenario. So when there's a big storm or a big hurricane, you have to worry about storm surges causing flooding, impacting septic systems and water supplies and causing soil erosion, and also leaching from crops and associated fertilizers and chemicals. When it's particularly dry, then potentially they have to increase their groundwater pumping, which can deplete the aquifers, cause problems associated with that. There's also increased risk of fires, increased heat impacts, and water stress on crops and various impacts like that.
Dana, you are always such a wonderful uplift to be able to summarize this. As Curtis says so on the chat, this has been great, and thanks to Dana, who makes things easy to grasp. That is a perfect summary. And you're also reminded at the end of bottom of any of the trainings we have on community to click that little green button, log your training, and indicate which ones you're liking. You can also give feedback on any of them that way too before you get credit. And last but certainly not least, after tonight, if you have any other questions, you can just go to cclusa.org/nerd-corner to be able to ask any other questions and join the robust conversation happening there. And his email, as well as our overall forums link, are there as well. But we like to route you, especially for this kind of stuff, right to where it's really happening at the Nerd Corner. We all know that. So with that, though, please join me. I'm going to unmute all lines so that we can give a huge round of applause to Dana and just thank him for excellent presentation, and thank all of you for being here tonight. Stay safe and happy holidays.
Thank you, Dana. Thank you, Richard.
Thank you, Dana.
That was great.
Thank you for listening to this episode of Citizens Climate Lobby's training program. You can tune into more episodes anywhere podcasts are available. Inspired by what you heard today? Join Citizens Climate Lobby to advocate for bipartisan climate solutions. Go to community.citizensclimate.org to find more trainings, resources, your local chapter, national action teams, discussion forums, and more. Be sure to like our Facebook page and follow us on Twitter and Instagram @CitizensClimate. We also invite all of our listeners to subscribe to our YouTube channel for more inspiration.
Like what you hear? Recommend us to your friends and make sure to give us a 5-star rating. It helps us show up on other listeners' feeds. Feel free to pass on any suggestions for future episodes in the comments as well.
And together, we are creating the political will for a livable world.